This is IAL C34 January 16. Question number 6. A hot piece of metal is dropped into a cool liquid. As the metal cools, its temperature T degrees Celsius. So T is temperature. T minutes after it enters the liquid. T is time. Is modeled by T is equal to 300 e to the power 0.04 T, that is negative, plus 20. Part A. Find the temperature of the piece of metal as it enters the liquid. So when it enters the liquid, the time is 0, so T is equal to 0. So the temperature will be (300) e to the power 0 will be 1 plus 20. So that is 320 degrees Celsius. Part B. Find the value of T for which T is equal to 180 degree. Now this T is 180 degree. And we have to find after how many minutes the temperature becomes 180 degree of the given metal. So 180 is equal to 300 e to the power minus 0.04 T plus 20. So e to the power minus 0.04 T will be equal to 80 minus 20 is 160 over 300, and that is equal to 0 cancel, 16 over 30, that is 8 over 15. Now we take antilog. We take the log, not antilog, log. So that is, this is ln and ln. So 0 minus 0.04 T is equal to ln 8 over 15. So T will be 1 over minus 0.04 ln 8 over 15. It means the value of T is, this is negative 100 over 4 ln 8 over 15. So T is negative 25 ln 8 over 15. So this is 0.6286 multiplied by, this is negative, so it will be positive, so it will be 15.71. Up to 3 significant figure, so T will be 15.7 minutes. This is 3SF. Part B. Now we have already done part B. Now is part C. Show by differentiation the rate in degrees Celsius per minute at which the temperature of the metal is changing is given by the expression. So we have to differentiate it. So T is equal to 300 e to the power minus 0.04 T plus 20. So dt over dt is equal to 300 e to the power minus 0.04 T multiplied by minus 0.04, and this is plus 0. So that is equal to 300 e to the power minus 0.04 T. You can see the answer is given 25, and what we have calculated is this one is minus 20 minus 25. So that is minus 1 over 25. We have 25 already, but we have this here and it wants the answer in this form. So we get a hint from here. You can see this T is equal to, if I bring 20 here, minus 20 plus. So 300 e to the power minus 0.04 T is equal to T minus 20. So this one I can write as T minus 20 divided by minus 25. So that is equal to 20 minus T over 25. That is what we are supposed to prove. Question number 7. This figure shows the part of the curve. This is part A. With equation y is equal to 3 ln x square plus 1 divided by x square plus 1. Find dy over dx. So dy over dx is denominator, that is x square plus 1, differential of 3 ln x square plus 1 is 1 over x square plus 1. The differential of x square is 2x minus differential of x square plus 1 is 2x plus 0 multiplied by 3 ln x square plus 1, and this is divided by x square plus 1 square. So that is equal to, this is x square plus 1 and this is x square plus 1. Cancel this. So this is 6x and this is also 6x. So that is 6x 1 minus ln x square plus 1 divided by x square plus 1 square. So that is the differentiation. Part B. Using your answer to pass F, find the exact coordinate of the stationary point on the curve C, for which x is greater than 0. Write each coordinate in its simplest form. So we have to find dy over dx. We already found dy over dx. So coordinate of the stationary point means dy over dx is 0. So this means, so for stationary coordinate, dy over dx is 0. So it means this expression is equal to 0. This will multiply by 0, it will, so only this numerator will remain. So this means 6x 1 minus ln x square plus 1 equal to 0. It says x is greater than 0, so it cannot be 0. It means only this one is 0, this portion. So we have 1 minus ln x square plus 1 equal to 0. So it means ln x square plus 1 is equal to 1. e to the power. So we have x square plus 1 is equal to e. So x will be e minus 1. So this is root. So we have this equation, y is equal to 3 ln x square. We put the value of x there. So y will be 3 ln x square is e minus 1 plus 1 divided by e minus 1 plus 1. So this cancel, this cancel. So y is equal to 3 ln e over e. So y is equal to 3 over e. So that is the value of y. Part C. Part C is the finite region R shown shaded in the figure 3 is bound by the curve x-axis and x is equal to 3. Complete this table. So we are going to put y is equal to 1 here. So it will be y is equal to 3 ln one square is 1 plus 1 2 over 2. So this value is 3 over 2 ln 2. 3 over 2 ln 2. Part D. Use Trapezium Rule with all the values in the completed table to find an approximate value of R, giving your answers to 4 significant figures. Now for the Trapezium Rule, we have to add this. So that will be the integral a to b y dx will be equal to half the width 1 minus 0 is 1 multiply sum of this extreme 0 plus 3 over 10 ln 10, and this multiplied by 2. So plus 2, 3 over 2 ln 2 plus 3 over 5 ln 5. So that is equal to half. This one is 0.6908, and this will be 4.0107. In fact, this remaining is just a calculation. You can do it yourself. So that will be 2.35075. And that is equal to, we have to find up to we have to find 3SF. So 4SF, 2.351. That is 4 significant figures. So that is the answer. Sometimes I don't give more emphasis on the calculation because at A level you must do your all calculation. What my idea is for you to understand how to solve a question.